Okay, so guys, now in this video we have to find the derivative of cos root x using the first principle method. Okay, and I was researching on this topic for a while and I found that this question is actually very difficult to solve using the first principle method. Okay, in the second part of this video I'm going to show you how you can solve this question much easily using the differential formulas method. Okay, so first of all we will use the first principle method. So we have y over here, so this would be our y, and then we can just make the increment, so cos x plus delta x, and over here y plus delta y, so y would move toward the opposite side of the equation and it would become negative, so we will have cos x plus delta x minus y. Now what is the value of y? We just know that y is actually equal to cos root x, so cos x plus delta x minus cos root x. Okay, so now at this point I'm going to apply a formula which actually says that cos a minus cos b is equal to minus 2 sine a plus b divided by 2 sine a minus b divided by 2. So this is the formula which we are going to use. A is x plus delta x root and this b is actually root x. Okay, so we are going to write it in this form, minus 2 sine a plus b. What is a? X plus delta x root plus b. B is actually root x divided by 2 multiplied by sine, same thing, a minus b, a x plus delta x root minus x root, okay, divided by 2. Now at this point I'm going to divide delta x on both sides of the equation because this is the way how this question is going. So we will divide delta x on both sides. There is a very important thing which I'm going to do over here. We know that in the next step, of course in the last step, we have to apply the limit, right? And while applying the limit in trigonometric functions, our main goal is what? We want sine theta over theta so that we can apply the limit of theta approaches to 0 and so it becomes 1, right? We want same angle in the numerator and of course in the denominator. So now how can we deal with it? We know we actually want to change our denominator so that it becomes equal to these things right over here. It sounds very difficult to do so, but I'm going to tell you how you can do that. We actually know that delta x can also be written as delta x plus x minus x. Yeah, it can be written as that because if I cancel x and x, then we will be left with delta x, which is actually equal to delta x. So it can be written like that, just like 2 can actually be written as 1 plus 1. Okay, so we have delta x plus x minus x. Now why are we doing this? Because if we just consider this delta x plus x a term and this x another term, this would actually be equal to x plus delta x root minus root x. Okay, so how are we going to do that? We can simply apply a root delta x plus x minus root x right over here. So you can see that we have the same terms which we were having right over here. But the thing is, we cannot do such a step by simply like this, because these two equations are actually not consistent. So how can we make them consistent? We can use a square over here. Okay, so the inverse function of a square root is actually square, power square. Okay, so if you see, if I cancel the square, I would be left with delta x plus x minus x, right? And this is the same thing which we are having over here. So now my equation is consistent. Now I can actually use the whole square formula. A square minus b square is equal to a minus b and a plus b on this term. So it would be delta x plus x root plus root x multiplied by x plus delta x minus x. So you can see now we have the same terms which we were having in the numerator right over here. Okay, so I can put these two terms in the denominator. So we have minus 2 sine divided by the same thing right over here. So we have delta x plus x with a root, and then we have x plus delta x with a square root minus root x. Now we have the denominator so that we can apply the limit, but there is one more thing. We have a 2 over here. And we have to cancel this 2. How can I actually do that? So if I just multiply and divide 2 in the denominator, so it would be 2 divided by 2, right? So this 2 would be cancelled. Now I'm left with minus sine. Don't forget this negative sign, is actually very important. Okay, divided by this thing, delta x plus x with the root, and x plus delta x square root minus root x divided by 2. Now I'm going to put 2 beneath one of these terms because these are actually being multiplied, so the 2 can come under any one of these terms. So I will keep 2 over here. Now if you see, we have this term right over here. Okay, so remember, we cannot apply 2 on both of these terms because this would be the case of multiplication or subtraction, that we can apply the denominator on all of the terms in the numerator. Okay, so we are actually multiplying, right? So in multiplication, we have to distribute the denominator to any of the numerators, to any one of the numerators present in the equation. So over here, I am choosing x plus delta x minus root x. Okay. If I keep the 2 over here, then of course this would be this 2 would be over here, and then I will apply the limit. These two angles would be same, and this thing would become 1, and this thing would be dealt later. Now what I'm doing over here, I'm applying the 2, I'm dividing 2 with this negative term right over here. So what will happen? I'm left with this term right over here. Now I can apply the limit. Okay, so we have the limit of delta x approaches to 0, and we can apply the limit on the terms which are being multiplied. So I can apply separately apply the limit on this function, and then I can apply the limit on this function right over here. And sorry, I forgot to put this term under this equation. Okay, so if I put wherever there's a delta x in the equation, we can actually put a 0 over there. So I will put a 0 over here and a 0 over here. So we'll be left with sine root x plus root x. It would be 2 root x divided by 2 divided by root x plus root x is again 2 root x multiplied by this. If we apply the limit on this thing right over here, this is actually x plus delta x minus x divided by 2, and this is x plus delta x minus x divided by 2. Both the angles are same. We have a trigonometric function. This would be 1, so we'll be left with 1. Okay, so this was our purpose of doing delta x is equal to delta x plus x minus x. Okay, so I hope you get the point. We are left with this term right over here. So we can see that the 2's are being cancelled, and we are left with minus sine divided by 2 root x, and this is the derivative of cos root x. Okay, so now let me just show you another method of solving this question. We can apply the differential on both sides of the equation, d by dx cos root x. Okay, and then the derivative of cos is actually negative sine, right? So negative sine root x, and what is the angle? The derivative of the angle multiplied by x power 1 by 2. Okay, so we have minus sine root x multiplied by the power would be at the beginning multiplied by x power negative 1 by 2. What just happened over here? We have shifted this power at the back of the differential. Okay, so we have 1 divided by 2 right over here. Then we have written the function x, and then we have subtracted this power and divided by 2 minus 1, which is actually equal to negative 1 by 2, and we've placed it over the changed function. Okay, the answer is exactly the same. We have minus sine root x divided by 2. This x can be reciprocated, and it will become x power 1 by 2, which is actually the same as this thing. Okay, so this question is actually very simple to solve.